Here are some very standard simple limits that we use while solving the sums. First is limit of a constant k as x tends to a is equal to k itself. That is simply because since k is a constant, its value is going to remain always the same wherever x might tend to. The second limit is limit of x raised to n as x tends to a is equal to a raised to n. So here we are basically replacing x with value a. Then thirdly, limit of p of x as x tends to a is equal to p of a, where p of x is a polynomial function in x. Then fourth limit is a very important limit, that is limit of x raised to n minus a raised to n whole upon x minus a as x tends to a is given by n into a raised to n minus 1, and here n can be any rational number. Now the proof of this fourth property can be seen later because it needs a method called as a substitution method that we will see later in this particular chapter. So now based on these standard results, let us solve few simple sums. Alright, here we have to evaluate the limit as shown here, x cube minus 8 upon x minus 2, and as x tends to 2. Now if we observe carefully, we can write the numerator as x cube minus 2 cube upon x minus 2 as x tends to 2, and we have just seen the standard result that limit of x raised to n minus a raised to n upon x minus a as x tends to a is given by n into a raised to n minus 1. So therefore if you compare, then n here is equal to 3, isn't it? Then a is nothing but the 2. So basically we have exactly same pattern as required in the standard limit. So therefore the answer of this would be n stands for 3, okay, multiplied by a raised to, that is 2 raised to n minus 1, that is 3 minus 1. So that is nothing but here we have 3 into 2 square, which is 4. So therefore the answer is 12. So that's the required limit, right? So in limits, typically we have to arrange the given expression into one of the standard forms and evaluate it. Now let's see one more question. Now if you observe here, the limit is to be found of the expression x raised to 3 by 2 minus a raised to 3 by 2 upon x raised to 5 by 3 minus a raised to 5 by 3 as x tends to a. Now this also is similar to the pattern x raised to n minus a raised to n upon x minus a, but we observe that here we don't have that x minus a which is required in the denominator. Moreover, if you observe, then numerator as well as denominator are of the type x raised to n minus a raised to n. So numerator and denominator both individually need the factor of x minus a below them in order to form the standard pattern. So therefore what do is we divide both numerator and denominator by x minus a. So here write it as x raised to 3 by 2 minus a raised to 3 by 2 whole upon x minus a, this is the numerator, divided by, in the denominator also we will divide by x minus a, isn't it? So that effectively we have not changed anything. Now there is one minor point here, that is when we say that we are dividing by x minus a, we know that we cannot divide by 0. That means we have to justify that x minus a is not 0. Only then we will be allowed to divide by x minus a. So how can we prove that? Now for that let us observe that we are given that x tends to a, right? So it means x is approaching a. So x has not become a yet, right? So that means x has not become equal to a yet. It is just in process of reaching a. So if x is not equal to a, it means that x minus a is not equal to 0. So therefore this particular expression x minus a is guaranteedly non-zero. So therefore we are allowed to divide by x minus a, right? So moving further, we can see that now the numerator is the standard pattern. So therefore writing the formula for that is n, which is 3 by 2, into a raised to n minus 1, that is 3 by 2 minus 1, correct, whole divided by, in the denominator here you have n, which is 5 by 3, and a raised to 5 by 3 minus 1, right? So that gives us 3 by 2 upon 5 by 3, that will become 9 by 10, right? And here in a, here you have minus 1 will get cancelled. Here you will have 3 by 2 minus 5 by 3. So the powers of a will get subtracted. So that gives us 9 by 10 into a raised to, now here we have 3 3s are 9 minus 2 into 5 is 10. So that is 9 minus 10 is 1 with negative sign, and the LCM is 6. So therefore that is the answer. If you want, we can write it like this: 9 upon 10 raised to, 10 into a raised to 1 by 6. That's the answer. So this is how we solve the limits based on standard results.